So for the next presentation, we have the contribution of Celal Güvenç from SOCAR R&D, who is going to be presenting online. So I don't know if Celal, you can hear me, or if you can talk, just to see if you're there.
Yes, I can hear you, Alejandro.
Perfect.
I hope you can hear me as well.
Yeah, I can hear you perfectly, and the audience here in the room as well. So thank you very much for attending today to this final event that we have organized for Photo2Fuel. Thank you very much for making some time for us and to make this presentation. Just to introduce you a bit, Celal has a background in chemical engineering and graduated from Middle East Technical University in Ankara, Turkey, specializing in the characterization of photovoltaic module performance and chemical reactions via concentrated solar technologies with applications beyond the lab scale. Currently, he's working at the state oil company of Azerbaijan Republic, SOCAR R&D, and Innovation Center in Izmir, Turkey, as the sustainability and decarbonation supervisor. So I'm really pleased to have you here today to gain some insights from your experience, from SOCAR experience in industrial R&D. So the floor is yours, Celal, to going up with the presentation. Thank you very much for coming again.
Well, thank you for the kind introduction, Alejandro. Let me share my presentation and move on from there. I hope you will be able to see it. Can you see it now?
Just give us a second. Yes, we can see it now.
Okay, great. Let me just activate related pointer. Okay. Well, Alejandro, thank you for the nice introduction, and I would like to also start by thanking to all the organizers, all the participants here for making this event possible and giving me the opportunity to share my experiences with our like Photo2Fuel Nefertiti project and our R&D efforts in general. Let me introduce myself briefly again after Alejandro. My name is Celal Güvenç, and I'm working as the Sustainability and Decarbonization Supervisor at SOCAR R&D and Innovation Center, which is located in Turkey. I will just start by giving you a brief introduction on SOCAR and what we do, how we do, who we are. And then I'm planning to go into more like tangible examples of specific examples of what we experience while trying to do integrations in the Nefertiti project. So SOCAR is basically an abbreviation. As Alejandro stated, it is State Oil, the abbreviation of State Oil Company of Azerbaijan Republic. Well, its headquarters is in Azerbaijan, and in the upstream operations are being conducted in Azerbaijan, which means that for the ones that may not know, just drilling and obtaining the raw materials, the natural gas, the crude oil, they are located in Azerbaijan. But the downstream operations, which are used to produce the end products we use in everyday life and in the industry, they are the premises, those premises are located in Turkey. Where in Turkey, as you can see from the screenshot on the bottom right, it is actually at the western coast of Turkey in the city of Izmir. And in the town of Aliağa, which is basically a petro city, let me say, petro town, and it's a peninsula. And there's basically a refinery, a petrochemical site, and other auxiliary facilities, let me say, storage, logistics, and there's a renewable energy plant as well. And speaking of SOCAR R&D and Innovation Center, it is actually structurally connected to the refinery and petrochemicals business unit. We call it RMPBU between us as an abbreviated version in the company. It is basically the main operations on the refinery and petrochemical sites. The thing about SOCAR R&D and Innovation Centers, it's structurally connected to these RMPBU, but it serves to all of the SOCAR premises around the world. It consists of 4 teams, Process and Technology Development Team, which I am also a member of, which actually consists of chemical engineers, basically. Product and Application Development Team, which consists of chemists heavily working on the petrochemical R&D, and an evolving biotech development team, and a dedicated project management office, which deals with all the administrative, financial, and legal things about the project portfolio of R&D. Taking a closer look to the area, Well, basically petchem and refinery is physically very close, actually connected to each other, because star refineries, that's why we call them integrated, as it is stated in the slide. Because star refinery is providing naphtha to the petchem, which is a raw material for petrochemicals, and that naphtha is cracked to the ethylene, and that ethylene is distributed along the petrochemical facilities for producing different products. Other than that, there is at the tip of the peninsula, there's a renewable energy plant, which is using the wind energy at the moment. And the logistics, the terminal, basically the port for import and export operations, and there's a storage area over here. And when we look at the red dot, the SOCAR R&D, we are basically at the interface between the operational area and the headquarters. To speak about the sustainability and decarbonization focus of the R&D, we have EU-funded projects. We don't have a big history with them, but we do have some experience, and we do have other collaborations. We really like to do collaborations with universities, with local and international universities as well, with private companies, with startups. And these collaborations mainly fall under 3 categories: energy transition projects, hydrogen technology projects, and circular economy projects. These can vary from year to year, but the numbers can vary, but the pillars are more or less this. For the EU-funded projects, we do have some experience on the integration and validation of CO2 capture, CO2 utilization units, and the one I will just mention, like a lower TRL projects like Nefertiti over here, because these 2 main projects that we conducted so far are innovation action projects, which are, as you all know, the higher TRL projects. And if you want to see a more extended list, you can just always visit our website to check all the projects and their summaries over there. Maybe I should mention you about Nefertiti a little bit in order for you to understand this slide better. The Nefertiti project aims to convert carbon dioxide and water into higher order alcohols using photochemical reactors, and it is using the natural sunlight as the only energy source. And SOCAR's duty on this project is to integrate and validate this demo unit system. And in order to make this possible, we realized that we are going to need a physical area where we can conduct indoor and outdoor experiments at once. Therefore, this slide shows you the first design selection that we made for the Nefertiti system. Our constraint was solar resources. We need to have enough solar resources. Therefore, we just did this type of analysis where these numbers are showing the hours of the day, and the lines are showing the amount of solar resources we are going to get. The longer the line, the higher the solar resources. Therefore, we just saw that this area, which is in very proximity to our main office and pilot area is important because that's where most of our utilities are connected to. Therefore, we can just extend those utilities towards here. Therefore, we just did our calculations technically and then just handed this to the civil engineering team, and they did some infrastructure analysis as well. And we decided that the alternative 2 is going to be suitable for our Nefertiti small solar lab, so that we can just do some integration and validation, both indoor and outdoor. Then we just focused our effort into the lab. Thanks to our friends at Leitat, Spain, they built this beautiful solar tracker. It's a manual tracker, but it can move in 2 axes, and it has special slots for our reactors, photoreactors, the lens places, and they just included a strap for us to put our light sources for indoor tests. The thing is, the consideration here is we were trying to produce a process flow diagram. We need to know the basic parts of our equipment as chemical engineers in order to, because this is going to be our main equipment and we are going to build around it. Therefore, we need to know this equipment, characterize this equipment really well. So after back-to-back discussions and in-person meetings with our friends at Leitat, we just plotted this PFD, this initial PFD, actually, this is an initial version, and just we realized that there's going to be a feeding section there's going to be a reactive section, which are going to be placed on the strut, and there's going to be a purification section where we need to also integrate into the system in order to get our products and analyze if any. So once we just decide on the main components of the element, the design gets easier. But of course, then we need to just go into all these three boxes, just go in detail and decide what's to be chosen in these areas. For example, first bump up just appeared after we just delved into the feeding section. We just realized that when you do these reactions in batch and in laboratory conditions, you can get super control over the reaction parameters and all these flows and concentrations. But when you try to do this in a continuous manner, on an upper scale, you may not get the same concentrations and you may not get stabilized flow. Therefore, we had to come up with different feeding scenarios. In order to do that, we've just had three different alternatives, providing us a little bit more flexibility on the process side, like feeding two-phase flows or one-phase flows with controlled injection of carbon dioxide into water vapor, or getting a heated area over here to pre-process our feed mixture so that it's going to be at the inlet of the reactor is going to be at the temperature and pressure that we would like, and it would not harm the reactor and it would not harm the reaction yield. And then we shifted our focus to the operational conditions again after cleaning the first box, let me say, first box in the process flow diagram. We just realized that in order to do outdoor experiments, we need a lot of physical flexibility on the system, which means that we can just bend the system in the X and Y axis while doing this solar tracking. But in order to be on the safe side, we need to be moving in this outdoor area. In order to do that, we do need to have everything extended towards the system. And one of the things that made this possible was in order to keep the flows safe and at the pressures, temperatures, and concentrations that we wanted, we had to use flexible tubing. And this was one of the design selections that we had to make. Other than that, for the small solar lab, for the interior facade, for the front facade and interiors part, there's going to be a lot of extensions for electricity, for power lines, for flow lines, for all the other connections to this tracker needs to be extended so that we can have mobility outside the solar lab. So because we cannot control the sun, we cannot control sun's position, and in order to have the amount necessary for the reactions to take place, we have to be mobile over here. Of course, these were the specific technical difficulties that we are trying to get rid of. But there are other inherent problems and company-specific problems as well, and I would like to mention them as well for you to have an idea. For example, let's start with the title as steering a big ship. I call this like that, and everyone probably knows what I'm talking about at the moment. The bottom right shows you a sample approval line I need to pass in order to do a construction work. Therefore, it goes to around 10 plus people, and I need to talk to them, and I need to let them know about the project and what we want to do and get their approval to start the construction. It can happen in other processes as well. This is the nature of the big companies. Big companies means a lot of people. So you need to just adjust yourself to just deal with all these kinds of managerial issues, let me say, and you need to keep a certain level of internal alignment to keep everyone together working on the project. And other than that, we can have some unforeseen items like MOC. These things usually come up in the integration and validation stage, because once you try to operate the system, once you're done with the building, you see that since you're connected to the utilities of the whole system, since you're connected to the power lines of the whole system, people come up and say that, okay, you need to let us know, make sure, show us on paper that this system is not going to affect our usual processes. Therefore, it is a back-to-back technical and non-technical discussions, again, as you may expect, to understand, to alter your system in certain cases, put some additional safety procedures or other things, process procedures as well, and adjust your system for them to be in line with the business as usual in terms of the technical side. And there are also inherent things like region-specific things. For example, Turkey is a non-EU country, and when our friends from Leitat wants to send that tracker from Spain to Turkey, they are bound to the Turkish customs. And it means that there needs to be an additional paperwork and additional meetings with the people at the customs or the agencies that are working with them. And we need to align ourselves with the right paperwork, and they need to align themselves from the Spanish side for the right paperwork. And we need to be meeting on in the middle to make this process of sending that physical parcel from Spain to Turkey seamlessly. So these are inherent things. You can change it. You can only adapt. I think this is the end of my presentation. Let me show you a recent picture from our team and from our building. This is extended at the moment. We are a bigger team with a bigger building. But I think this is the end of my presentation. And if you have any questions, I would really like to answer them. Thank you.